Okay, this is a realistic TRC 457. If you've watched the other videos, you've seen that this was a new old stock radio. So there's absolutely no modifications done to it. The only thing that has been done to it is the electrolytic capacitors have been replaced. I have not even done an alignment on this yet. So this is as it left the factory, decades ago. And it's as it is a good working radio. But I want to show something. There is a very popular modification that's done on these radios. I've done it for a lot of people over the years. A lot of people request it. This uses a very popular, now it may be realistic, say realistic on the front, but anybody in the know with CBs knows that's not who made it. It's a Uniden. Now this has a PC-196 BD main circuit board. And this circuit board is used in numerous other radios, including, of course, Unidens, President, and a bunch of other radios. It's a UPD-858 PLL-based board. Now, the modification I'm talking about is an audio modification. It's extremely simple to do, or it's as simple as you make it. But basically what you're doing when you do this modification is you're taking this coil, and 5 small poly-dip caps out of circuit. This one, this one, this one, this one, and this one. Now, you can remove all 7 of those parts, these 3 big caps, the 2 small ones, and the 2 coils, or you can just leave them in the radio. The audio basically comes in one side, in the coil here. This capacitor here is in parallel with this coil. This capacitor here is in parallel with this coil. And then these are connected, these 2 coils are connected in the center. But it goes in one side and out the other. It's just a filter stage. And then these 3 capacitors here go to the end of this cap, hooks up in the middle here, and then to ground. And this one hooks up in the center to ground, and then this one hooks up at the other end to ground. And it's used to limit the audio bandwidth. Now, like I say, a popular modification is to disable this section. You can remove them all, you don't have to. All you have to do, honestly, is run a wire from the outside edges of the coils, the 2 outside pins, basically just run a jumper straight across. That's all you got to do. Just take a piece of, cut off terminal from a capacitor you just changed, and you can put a jumper wire in there. Now you can remove all of them, do the same thing, but you'd still need to run a jumper wire to connect those traces, so there's a continuous audio path. But what I want to show is what that actually does in the RF spectrum, for better or worse. I'll leave that up to you. This is the first time I've actually looked at it to see what does it do in the RF spectrum. People do this to broaden their audio. Now, in my opinion, I'm probably never going to recommend this modification again. Now, I might recommend maybe slightly modifying it, slightly changing some values, but disabling this circuit, no. I don't think I would ever recommend doing this again now that I've actually looked at it on a spectrum analyzer. It's one of those things you do modifications, you hear it through the grapevine, you've been reading it in magazines and books for 20, 30, 40 years, how great of a mod this is, but nobody ever seems to do actually any testing to show what does it actually do for you. Is it good or bad? Now, is it good or bad is actually really going to be dependent on what microphone you're using, in all honesty. The audio this thing filters off, it's only going to filter it off if it gets there. And if your microphone does not have the frequency of response, once you basically bypass this, well, if you hook up a microphone and it doesn't have a flat audio response that rolls off on either end, you're still not going to gain any advantage. And looking at it, it actually only benefits you in the high frequencies. A lot of it to the point where it's almost ear-piercing. And I want to show that. So the test setup that I have, we're not going to be taking any direct measurements. This is just looking at the spectrum analyzer, RF. We're going to be looking. Okay, so we have the radio. I have microphone hooked up here. Actually, it's not a microphone. So what I have is just a little jumper I use when I'm testing radios. But what this is, this BNC cable, if you follow it, you see that it goes over to the communications test set that has a modulation generator. So basically an audio generator. And I can change the frequency over there. And then the quarter-inch phone jack here just runs down to a foot switch on the floor so I can key the radio. And that's the main reason I made this thing up, because a lot of times I need two hands when I'm working on a radio. But that's the test setup. So we're running a audio signal from an audio generator out of that straight into the mic input, and then I have the output of the radio, in other words the coax jack, is run into the input on the communications test set. Okay, that runs in, and then there's another jack on the other side there is for hooking up external test equipment. That's the RF direct out jack, so I can hook up and what I have is there's a built-in 20 dB attenuator in between the input and then that output. So then I have that then run over to the spectrum analyzer. And then I have I always feel better safe than sorry, so I have another attenuator there just for protection of my equipment. So there's another 20 dB attenuator there. So actually it looks like I need to actually put that on there. Reference offset 40 dB. There. So now that's actually properly set. So we'll turn the radio on. And what I've done, actually, before I turn it on, I need to flip it up. Because what I did was I installed a toggle switch to bypass it on the underside. Now, like I say, this is 100% original radio, other than the electrolytic capacitors have been replaced. Has not had an alignment. It has never been tinkered with by anybody. No modifications. It's a new old stock, and means just that. It was brand new. It just recently got removed from the box. Doesn't matter how old it is. It's never been tinkered with. So the modification that I've done is basically, this is what you would normally do. These four terminals right there are those two coils, okay? And what I've done is I've just run a wire. Normally you would just jumper between those 2 points, and that bypasses those two coils and those 5 capacitors. So I've installed a toggle switch. So in this position, the toggle switch is off, so that means the radio is as it is left. It left the factory, and when I flip the switch, it closes the contacts in this switch, which would be a modified radio. So now this is basically just a jumper. It's completely bypassing it. The audio comes in the switch and then goes out the other side. So it's bypassing that filter circuit. So what we want to look at is the spectrum analyzer. So I have it set basically to view 3 channels. Get her turned up here enough. A little more. Okay. So I have the left-hand side of the screen is 27.170, and the right side of the screen is 27.2 megahertz. So that basically encompasses 3 channels. The center, 27.185, the frequency we're talking on. Of course, the edges of the CB channel spacing is 10 kilohertz. So 27.185 actually starts at 27.18 and ends at 27.19. So, and then add 10 kilohertz to either side of that. Now that actually is not a CB channel here, which will be represented here because there is a missing channel between channel 19 and 20. But that missing channel ends at 27.2 megahertz. And then, of course, channel 18 starts at 27.17 and ends at 27.18. The center of it being 27.175. So I'll turn the radio on, and then what I'm going to do is I'm going to push my foot switch, and actually let me make sure I have the switch turned off so the filter's in. I'm going to set my frequency to 1 kilohertz, and I'll turn the internal speaker in the communications test setup so you can actually hear that frequency. Okay, so there it is. That's 1 kilohertz, modulated 100%. Actually, we can swing back over here to the communications test set so you can see it actually is doing 100% modulation. It's actually doing 17.5 watts peak-to-peak power. being fed a 16.8 millivolt audio signal out. Now I actually have some padding at the input on this this jack that I have, and that's just to protect the radio a little bit. So there's the setup, and what I'm going to be doing when you hear me over here, if you hear buttons pushing, that's just going to be me changing. Actually, if I key the radio, that's the audio frequency right there. So if I go to 2 kilohertz, 1.5 kilohertz, that's what I'm going to be doing, changing the tone, or changing the audio signal going into the spectrum analyzer. So there's 1 kilohertz, which is the normal test tone used when you do an alignment on a radio. And that's with the filter in. Just give it a second, it just went into calibrate mode. It does that every once in a while, and always seems to do it to me when I'm on camera. Let's start over. So there's with the filter on, filter off. So filter, what I'll say is actually filter in or filter out. So there's the filter out and filter in. Not a lot of difference, but a little bit. Actually, I had that backwards. That's filter out. That's filter in. And you did notice some of these other side bands here did drop a little bit. Now you have to remember, this center peak is the carrier frequency. So actually, if I turn off the modulation generator, see, there's our carrier. Now if I turn the modulation back on, okay, so this is our upper side band and our lower side band. Actually, all of this crap out here, this is actually what we don't want, okay? All these other byproducts of transmitting. And we want those to be as low as possible. That's normal, though. That's normally what you're going to see, a bunch of little spikes, but you see how they taper off drastically. So, by the time you get from here to here out to the next channel, it has dropped considerably. So, like I say, there's with the filter in at 1 kilohertz. Now let's change that to, let's say, 500 hertz, a really low tone. Hold on a second here. Oh, for Pete's sakes. I done hit the wrong button here and got myself all screwed up. Okay, let's try this again. Turn the volume up so you can actually hear that signal. Now I'm going to change it to 500 hertz. I don't know how well that'll show up in the camera, but okay, there that is. So that's with the filter in, filter out, filter in, filter out. So not really much difference to speak of. Okay, let's change that to, say, 750 hertz. Okay, so we can see now we do have some sideband power. And that's with the filter bypassed. And that's with the filter in circuit. So, filter in circuit, filter out. No real difference. So we can see it's not really affecting the lower frequencies. Let's change it to, let's say, 850 hertz. No, I guess it would help if I type to 0, not 85 hertz. Okay, so there's 850 hertz. That's with the filter out, or bypassed. That's with the filter in, filter out, filter in. So we can see no real difference. So it's obvious this filter is obviously for high frequencies. So let's try at 1.5 kilohertz. Because we already saw it didn't do anything at 1 kilohertz. So there's 1.5 kilohertz with the filter in, filter out, or bypassed. Filter in. Now notice, some of these other little spurs here are starting to pop up. This is with the filter in and filter out. When I bypass the filter, you can see they did come up a little bit. Let's go to 2 kilohertz. So there's with the filter bypassed, filter in, filter out, filter in. So we can see that with the filter is definitely rolling off a lot of those high frequencies, and it's cutting down on a lot of those, that side crap that we really don't want, that causes adjacent channel splatter. So filter back off. So we can see how they come up when we bypass the filter. And you can actually see the power on those sidebands really is not changing that much. You can just barely see it, barely the width of a line. But we're really starting to pick up a lot of adjacent side channel, splatter. So let's go to, we're currently at 2 kilohertz, so let's go to 2.5. So there's with the filter bypassed, filter in, filter out. Or wait a minute. Yeah, that's filter out, filter in. Actually not seeing a big, huge difference there, but some. So there's, let's go to 3 kilohertz. So there's with the filter in, filter out. Aha! We've found the magic spot. Obviously. So let's actually drop down a little bit and see where this filter starts to lose effectiveness. So let's go down to 2.9 kilohertz. A little bit popping up there. 2.8 kilohertz. Yeah, okay. Right around 2.8. So there's with the filter in, filter out, filter in, filter out. That's really where you can start to see the filters, the end of its, or the edge of its range is right there. So we'll go back to 3 kilohertz. That's filter in, filter out. Let's go to 3.5 kilohertz. There's filter out, filter in. Very clean signal. Filter out. Holy shit. Filter in. Go to 4 kilohertz. There's filter in. Now notice we have almost no power getting out. It has completely blocked it. There's really just a carrier and nothing else. And then we'll bypass the filter. Yeah. And we can see, actually I need to widen the span. We're now out into the 2 channels on either side. We're really starting to bleed into it. There's filter in, filter out, 5 kilohertz. There's filter bypassed, filter in, and we can see we're absolutely no modulation whatsoever with the filter in. Bypass the filter, and actually I want to increase the span, because right now it's 30 kilohertz. I'm going to increase it to 50 kilohertz. Not 50 megahertz. Damn it. There's 50 kilohertz. So we can see, yeah, we're definitely starting to, and actually, darn it. I need to change my resolution bandwidth back. Bump it up a little bit there. There we go. Yeah, we can see. So there's filter bypassed, filter in, filter out. So we can obviously see that that's not really going to do us a lot of good in reality, because the human voice range, unless you're a chipmunk or some little furry critter that has a really high-pitched squeak, bypassing that filter is really not going to do a lot for you. In all honesty, if you have, in your room where your radio's at, if you think about it, a lot of noise that you'll have in your background, fans and other stuff, that's that's usually some high-pitched noise. So actually with that filter installed and left factory, it would actually help to block some of that stuff. So yeah, honestly, it's not the probably the greatest idea. Like I say, I have done those before. People, want that done because, like I say, it comes down to it. You read about it all the time. Everybody always says, "Oh, that's such a fantastic mod. What it, really widens up your audio." Well, yeah, it does. But honestly, it really starts at what? What did we see? What was that? 2.8 kilohertz. That's where the filter really starts to come into play, somewhere around 2.8 kilohertz. Honestly, you're listening to my voice right now. I can pretty much guarantee you there's not much of my frequency range in my voice that's around 2.8 kilohertz. Most of it's lower frequencies. Now, like I say, if you have a really ultra high-pitched squeaky voice, yeah, probably bypassing the filter might actually do you some good. But in all honesty, I'm going to have to start recommending not to do that modification because it's really not doing anything but causing adjacent channel splatter. Now, granted, this is a stock radio running stock power. Like I say, actually, honestly, the modulated power is actually a little bit high on this because I haven't done the alignment on it yet. But once I do the alignment, everything will be set to factory specs. But you'd almost have to be sitting next to this radio with a radio turned to a different, to an adjacent channel to notice it once you get out any distance. But for people that run antenna heaters, yeah, if you run an antenna heater, that would be the easy way to turn your station from clean running station into an absolute splatter box, would be to bypass that filter, honestly. And like I say, I'm going to tell you the honest truth, I'm guilty. I've done a bunch of those mods before and never gave it a second thought to take a look at it in the RF spectrum, and now that I have, yeah, I'm not going to recommend it anymore. The gains you're getting are in frequency ranges that you really are not going to benefit you that much. So there's just my thoughts on bypassing the audio filter section on one of the Uniden PC-196 based circuit boards. So I thought I'd actually show that test. So now actually, it's not just all conjecture and people saying, "Oh yeah, that's a great mod," and well, honestly, what proof do you have that it's good or bad? So you actually saw some measurements there to show what it does, and what it does do is create a lot of adjacent channel splatter. So the Uniden stuck that filter circuit in there for a reason, and I'm going to have to say that filter circuit should stay in circuit. Now, could we modify it slightly? Yes. The problem with bypassing it is it does just that. It completely bypasses it. Now, you could tailor the frequency range of this by changing the values. So, we can play with the values of the coils and these capacitors here. By changing those slightly, we could broaden it a little bit. So, like I say, this filter, you could see, really does absolutely nothing for low frequencies. It's mainly a high frequency filter circuit. So, if you wanted to increase your high frequency range just a little bit, not enough to where you're going to be causing a lot of that adjacent channel splatter, but if you wanted to increase it maybe an additional 500 hertz, that wouldn't be hard to tailor this circuit here to increase it just a little bit. Like I say, just a little, recalculate. Not that hard actually to figure out, do the math on this circuit here to see what its range is, but just change it a little bit to broaden it maybe slightly. But as far as bypassing it, I'm going to say no, not a good idea. So there you go. There's my thoughts on the audio mod on the PC-196 circuit boards.